Alright everybody, today I'm going to show you how to make this rolling ball animation in Blender geometry nodes, with the ball actually sticking to the ground while rolling. To do this, we are going to add one or multiple curves of your choosing. We are going to use a sample curve and a curve length node to ultimately drive the rotation of the balls so that they actually rotate and move in a physically correct way. We will also use the sample curves node to procedurally set the position of the balls so that we can actually achieve a looping animation. And in the end, I'm going to show you a neat little trick how to easily set the position of the balls so that they actually roll on the surface and not through the surface. In the end, I'm going to walk you through the lighting setup as well as the simple shading I used for the balls as well as for the ground floor. Okay, so now let's actually finally start the node overview. For projects like these, I actually like to use a curve selection or a anything selection mechanism just to make everything a little bit more procedural. The way I do this in this case is using a switch node set to geometry. This way I can, for this purpose, switch between a curve circle and a curve line node. I can show you this right here. If we play the animation, I have the curve circle active right now. I select the switch node right here, and I do have the curve line active right now. You can, of course, totally leave out the switch node. You don't need it. You can directly select just your curve circle and your curve line and go from there. After you have added the curve of your choosing, you're going to feed this curve into a sample curve node. I personally have renamed this sample curve node to sample curve, rotation and location. That is just so for this tutorial you can easily see where this node right here actually feeds out to. In this case, this is actually going to be our rotation logic as well as our location logic where this sample curves node is actually going to feed into. This sample curves node will actually allow us to animate the path of our sphere along the curve we selected previously. We will do this by adjusting the factor amount of this node. The factor of this curve, if I plug my value node out right here, is actually between 0 and 1 for the entire rotation. So you're animating a value between 0 and 1. I personally, for this case, use a value node plugged into here, and I've already animated this value node so that it seamlessly loops between 0 and 1 in the span of 300 frames. From there, the sample curves node is actually responsible for two paths. One of the paths is the rotation logic, the other one is the location logic. Let's look at the location logic first. For the location logic, we are going to use the position output of our sample curves node and feed that into the position input of a set position node. For the geometry of the set position node, we are going to use a mesh line with a count of 1. So the reason we are using a mesh line for the geometry input instead of the sphere itself is that the set position node actually sets the position of every single vertex in an object to be at the same location, which actually would condense a sphere to a single point, and we obviously don't want that. So we are going to use a mesh line in the location logic and then later instance a sphere on that singular vertex point of the mesh line. Speaking of instancing, let's actually look at that right now. Let's zoom out a bit, go over to our instancing section, where you can see that the geometry output of our set position node is going to be fed into the points input of our instance on points node. And now finally, as previously explained, we add a UV sphere, which we will feed into the instance input of our instance on points node. I personally also added a subdivision surface node, which is completely optional, as well as a set material node, which is not optional if you want to add materials to your spheres. Just as a little side note, I very much recommend that you will drive the radius of your UV sphere right here by a value node. The reason for this is that you will use the value of the radius of your UV sphere on multiple points in this node setup. That being said, let's finally move on to the rotation logic of this setup, which really is the core concept of this entire node setup. Let me give you a little demonstration. Ball rolling, full setup working, but now if we disable our rotation logic like this, you pretty much just have a floating ball, which doesn't really look that appealing, does it? So let's re-enable our rotation logic just like this, and let me walk you through the setup. First, let's look at what nodes are actually in use here. Let's zoom in right here. We do have a curve length node. We do have multiple math nodes. We do have a math node set to multiply. We have one set to divide. We do have a combine XYZ node. We also have a rotate rotation node and an align rotation to vector node. These nodes in our rotation logic are connected the following way. We do have our original curve, which is directly being fed into our curve length node. We then have our tangent output of our sample curves node, which, as you can see right here, is being fed into the vector input of an align rotation to vector node. We are feeding our curve length node into the bottom input of our math multiply node. We are then connecting the value of the factor that is being fed into our sample curve node right here into the top input of said math multiply node right here. We are then going to feed the result of that math multiply node into the top input of a math divide node. We then use the value that we also fed into the radius of our UV sphere. Basically, we are just going to use the value of our sphere radius right along this path, going to feed it into the bottom input of this math divide node. The result of this math divide node is then being fed into the y input of a combine XYZ node. And then lastly, the combine XYZ node's vector is going to be fed into the rotate by value of the rotate rotation node, and the align rotation to vector node is going to be fed into the rotation input of the rotate rotation node. And also, just as a little additional side note, make sure that your align rotation to vector node is set to the x-axis, pivot is set to auto, and the factor is set to 1. Also, make sure that your rotate rotation node is set to local. Also, if the rotation values don't line up for you, try playing with the x, y, and z value of the align rotation to vector node, as well as the x, y, and z inputs of the combine XYZ node. In the end, the rotation output of the rotate rotation node is going to be fed into the rotation input of our instance on points node. After that, you are theoretically already finished with the node setup, but I do recommend you'll do 2 more things. Firstly, let me just demonstrate what this little setup right here does. Let's mute those nodes, and as you can see, the sphere falls into the ground, which actually would be its original position if we just kept it on the instance on points node. Now let's actually unmute those nodes again and explain what this setup does. I am taking the radius of our UV sphere, which we drive by this value node right here, and I'm adding it to the Z translation of our transform geometry nodes, which basically just is fancy talk for lifting the sphere up in the Z position by its radius, which makes it actually be perfectly flush to the floor. Lastly, what I like to do in setups like these is add one last transform geometry nodes, which basically allows me to scale the entire setup we've done to this point. After that, if you want multiple rolling balls in your animation, it's basically just copying this entire setup right here and in the end, after this master transform, joining them together. For use cases like that, your master transform will also be very helpful by giving each rolling ball a different location. And this is what the whole setup would look like if we copied it over multiple times. As you can see, each little section right here has a different master transform. As you can see right here, we have all 0, 0 for the translation. If we go over to the next one, we animated a different path via this master transform. We added some X and Z location. In another one, we might even add a little bit of set rotation to the path, just so the sphere starts at a different point than the others. But I do think that's going to be enough for the geometry nodes setup itself right now. So let's look at some lighting and shading. Let's switch over to the shader editor and let me walk you through the simple shading I've done for the spheres as well as for the ground setup. So the shading for the ground floor is actually me just manipulating the roughness input by adding a Voronoi texture, manipulating the coordinates of the Voronoi texture with the noise texture added after a texture coordinate and a mapping node. You can see the values I've chosen for my noise as well as my Voronoi texture right here, but I do recommend that you just play around a little with the values you see right here and basically just end up with what you like the most in the end. The only other thing that I've done for the ground floor shading is actually add a little subsurface scattering using these values right here. But once again, I just recommend that you play around with them a little and end up with what you like. Let's actually switch over to the shading of our spheres right now. I have made 5 different sphere materials, but all are set up basically the exact same. In the principled BSDF, the only thing I've done is drag the roughness value all the way to the left, so it's basically 0. And after that, I've manipulated the base color. When I zoom in right here, you can see it a little better on this particular sphere by using a Voronoi texture and a color ramp set to constant. This way, I can use the Voronoi texture, which is actually in this case set to distance to edge, to drive multiple colors to appear in this Voronoi pattern right here. After that, it's just setting a different color scheme and scale for every single sphere you can see right here. Lastly, for the lighting setup, I've basically just chosen 3 area lights, but once again, for this situation, I just recommend that you play around with a lighting setup that you like, that you play around with the camera position that you like, and make this animation basically your own. If for some reason you just want to play around with this particular file right here, it is available as always completely free in the description down below to download. And as always, I'm very much trying to improve my tutorials, so if you have any suggestions on how to improve the channel, please leave your comments down below. Bye bye, see you in the next one.